All righty, let me go ahead. Share my screen here. Okie dokie. All right. Well, good morning / afternoon / evening, everybody. I'm just starting everything right now while waiting for attendees to join. So that all should be going through in just a minute here. And let me see, my audio level should look good. Let me just double check that. Yep, perfect. Yep, that looks good. Okay. Go ahead and close that. All right. Okay, we'll get started in a few minutes here. I'm just going to go ahead and give everyone a chance to fill in. We have like a couple hundred registrants for this webinar, so I'm going to go ahead and give everyone a second to come on in. Stephen, Craig, good to see you. Well, I've got some good stuff for everybody today. I've been working a lot on my code samples, and not to mention we just got the first OpenTelemetry version of Phobos went live on SDK bin yesterday, so that should all be available now. So I'm looking forward to sharing some of that. Go ahead, pause my screen share for just a second here. All right. Good stuff. Okay. All right, we'll go ahead and get started right at 10:30. So just a couple more minutes. We'll wait for people to file in here. And actually, while I'm here, I might go ahead and put a little poll together. Yeah, that's all right. Greetings from Lichfield in the UK. Well, Christopher, I'm hoping at some point in the not too distant future here, I'm going to be able to go back to actually traveling for conferences and working with customers. I used to go to the UK 3 or 4 times a year, since that's probably our Petabridge's biggest group of customers outside the United States, is probably either there or in maybe in Sweden and Norway. But looking forward to being able to finally get out and about again after 2 years of not being able to do that. Bagif, good to see you. I know I owe you a reply to an email, so apologies for that. Been working very hard on getting this version of Phobos ready to go for this webinar today. All right. Well, it's just about time for us to get started. So I'll go ahead and pick that up in just a minute here. All right, it's 10:30. So I'm going to go ahead and get everything started here. So my name is Aaron Standard. I am the founder and CEO of Petabridge. We're the company that does most of the development behind Akka Net these days, and I'm one of the original founders of that project. And today I want to talk about a project that I've been working on quite a bit for the past couple of months, although really I started my work with OpenTelemetry back in May of 2020, so it's actually been closer to a couple of years. But OpenTelemetry is a big thing that's happening right now in the .NET ecosystem overall. And in particular, it's really going to be an interesting change the way we are used to observing Akka .NET applications as well. So I want to start today by talking a bit about OpenTelemetry. Why should you care about this? Why is it important, and why now? Why are we talking about OpenTelemetry today versus 6 months ago? Next, after we've gone through that, we're going to talk a bit about OpenTelemetry's basics. OTel is a common abbreviation for OpenTelemetry in all of the literature out there. So that's something that you'll go ahead and see thrown around quite a bit. Next, we're going to talk a bit about Phobos and Akka Net. So how do we use OpenTelemetry to observe Akka Net using Phobos? We'll talk a bit about some of the data we can visualize coming out of OpenTelemetry and how to make some dashboards using Grafana to go ahead and do that. And then we're going to talk a bit about known limitations and some best practices with OpenTelemetry as well. So for instance, one thing you may have noticed if you've gone onto NuGet and taken a look at any of the OpenTelemetry binaries is you'll have noticed that they're all in a release candidate stage right now. I'm going to go ahead and address that as part of our webinar today as well and talk a bit about why that is and how that's going to change down the road. So hopefully we're going to go ahead and cover all this in the span of about 90 minutes tops. So if you attended the webinar I did about a year ago on Phobos and basic DevOps practices for monitoring Akka Net solutions, I stole these slides directly from them. I want to go ahead and kind of set the context around OpenTelemetry in terms of why this matters to application developers. And these slides did a good job of explaining it. So there's two different facets to how we need to monitor our applications in production. The first is traditional monitoring. These are metrics-based approaches for trying to quantify the state of our software. So we measure things like error rates, message processing throughput, maybe latency is something else we measure. And these are primarily tools that get their data piped into dashboards and they power alerting systems and that sort of thing. That's a fairly well understood practice that's been in place for 3 or 4 decades now. So there doesn't really need to be a huge amount of basic explanation for why that's important. You basically need it to understand how well your software is performing. Observability is a much more nuanced and relatively recent subject area, though, where observability is less about the operations side of running an application and more about the development side. It's trying to understand what happened in the course of fulfilling a customer's request and why it happened the way it did. So it's used for troubleshooting and debugging. This is particularly important now that microservices and distributed systems are becoming more and more common amongst, even pretty traditional software businesses like insurance, for instance, have these types of technical problems. So we have to have some way to connect the activity that happened in one process and with the activity that happened in another. So this is distributed tracing, which is basically what people really mean when they talk about observability for the most part. So my argument is that most applications really need both in order to properly manage and develop important production systems. You need metrics and alerting, so you get notified about, let's say, outages or a big surge in failure rates. And you also want to be able to do this to do things like performance optimization too. The most common practice for people who are building customer-facing web applications is to look at metrics like 99th percentile latency. These are the customers that were given the absolute worst experience in terms of latency and performance on your site. And developers will usually work pretty hard to try to flatten that latency curve by reducing that number. So that's what monitoring is for. That's important. And why observability is important is this allows us to understand user-driven behavior that is dynamic, meaning it's something that you as the software developer couldn't necessarily plan or predict when you built the system. Because user behavior is non-deterministic, and we need some way to be able to walk backwards from what the system did and how it did it in order to efficiently debug and fix problems that occurred with it. So tracing, and I also mentioned petabridge.commands, another good example of an observability tool here, using some of its interactive commands to query or even nudge system behavior. And yes, I kind of already went over this. Monitoring helps you basically understand how things are running right now. Observability helps you understand why something happened the way it did. And ideally, you need both. And this is what OpenTelemetry does for application developers and framework developers like us here at Petabridge. OpenTelemetry provides a unified standard on how tracing, logging, and metrics are all supposed to be propagated in order to work with APM vendors who are all on board with this initiative. So one of the big problems that we've had, sort of historically, is that every APM vendor, so APM stands for Application Performance Monitoring, and APM vendors include companies like Microsoft. So Application Insights is an example of an APM service they sell. But it also includes open source technologies like Prometheus and Jaeger. And there's also a bunch of third-party APM vendors. Datadog, for instance, is very popular with Petabridge customers. That's another good example. So one of the problems that library and framework developers have had is that making a reliable distributed tracing or even a consistent metrics experience for all of our users has been very cantankerous at best. Typically, the way developers have done this in the past is similar to what ASP.NET does, where they'll go ahead and expose certain stages in their pipeline that can be overridden. And it's kind of up to the application developer to inject their own preferred telemetry code inside of there. And that's a very painstaking and costly experience for most of them. So on top of that, it's, basically we essentially force the developer to go ahead and do all of this work to figure out how to tie all of their different libraries and frameworks and systems together into a coherent picture. And you almost needed, in a big company, a team of dedicated like DevOps and observability people to do this. With OpenTelemetry, we now have a consistent experience that every library can implement. And there's a straightforward way to tie all those disparate traces and metrics together into a coherent picture, and it's very inexpensive. So it reduces the total cost of ownership for developers like you who are actually building real applications. It also solves a major problem for people like Petabridge, which is the framework and library developers. Now, if we want to go ahead and provide some way for our users to observe how our library is performing, we have a standard way of doing that now. We don't all have to come up with our own bespoke way of trying to expose this behavior to end users. Now there's kind of a formula we can all follow. And so this helps reduce some of the overhead in our own, let's say, development cycles, where we have to plan on how can we make it possible for our users to observe what's happening here. And then finally, this is my favorite, but one of my most common problems I have to troubleshoot around Phobos is this one, the my graph looks funny in Datadog problem. So we use app.metrics in the 1.x versions of Phobos today. And app.metrics was an attempt to solve the same problems OpenTelemetry is solving. But the way they tried to do it was to come up with a common vocabulary for all the different metrics types and translate them all into the different little weird ways each APM vendor does things. And as a result, you get these inconsistent experiences despite the fact that the inputs are the same. Well, what this does is, since all of the major APM vendors are responsible for supporting the OpenTelemetry protocol, and they have to write what's called an exporter to go ahead and export traces, logs, and metrics back to their service. So Datadog has to write their own exporter library for this stuff. If Datadog renders an OpenTelemetry graph differently from someone else, that is now Datadog's problem, not my problem. So this, again, helps reduce the total cost of ownership, and it kind of forces all of the major APM platforms to agree on a common lexicon for how traces, logs, and metrics are supposed to work together. And this will help improve the consistency with how individual libraries like ASP.NET and Akka.NET can be observed inside those systems. So overall, this is a very useful development in the, not just the .NET ecosystem, but every major runtime is supporting this, including C++. So everyone is basically kind of getting behind OpenTelemetry because it solves this painful, disparate, heavily siloed problem. Now let's talk about OpenTelemetry in .NET specifically. The reason why we're talking about this now is that as of the .NET 6 release, which happened this past November, OpenTelemetry is now the official solution for all of Microsoft's frameworks for observing them. This includes stuff that's built into the base class library, such as the SQL clients and the HTTP client, all the way up to bigger things like Entity Framework and ASP.NET. And so the OpenTelemetry primitives are all built into .NET 6 going forward, but they also ship as a standalone NuGet package, the system.diagnostics NuGet package. And that's backwards compatible all the way to .NET Standard 2.0, which is what Phobos and Akka Net both target. So as long as you're using .NET Framework 4.61 and later, you have telemetry support for this. Microsoft even offers instrumentation for classic ASP.NET, meaning like not ASP.NET Core. I mean, the stuff that we were doing back in like 2013. There's even support for that built into the official OpenTelemetry repository. So there's going to be a broad range of use cases all supported by OTel going forward. Microsoft is very deeply committed to this. So the base types for supporting OpenTelemetry tracing and metrics respectively are both built into these different namespaces in system.diagnostics. But those types are also wrapped around the OpenTelemetry APIs via the OpenTelemetry NuGet package, which is what we're going to be using today. And that's what Phobos depends on as well. So we're basically going to be calling some of the OpenTelemetry sort of APIs, but really under the covers, they're using these two, which are all designed to go ahead and support the OpenTelemetry specification. Now, if you followed me on Twitter, you may have seen me post a thread 2 or 3 days ago about how impressed I was with the way the OpenTelemetry metrics library is designed. OTel has been built from, so Craig asked the question, should we use the NuGet package over system.diagnostics? They have a guide on the OpenTelemetry repository that says when you should use each. In my opinion, I think you're probably better off using the OpenTelemetry NuGet package because you get access to everything. There's a couple of APIs that aren't really built into the system.diagnostics package. A good example of that is the propagation libraries for being able to extract trace context and pass it over the network. So if you're using a tool like, let's say, RabbitMQ, for instance, you're probably going to need to be able to extract your tracing context, inject it into some headers on the messages you send, and then extract that context again on the other side. I'm going to link to an example in this presentation that shows you how to do that. But that's an example of something that you get out of the OpenTelemetry NuGet package that you don't get from just using system.diagnostics.activity. Now, if you're only using, let's say, ASP.NET and the HTTP client, you can get away with only using the built-in diagnostics tools. Because they automatically handle propagation for you through the HTTP headers on both the ASP.NET side and on the HTTP client side. So yeah, quite another question from Vigif. Some of our services need to wait with upgrading to .NET 6. They're on .NET 5. Will they be able to take advantage of the latest OpenTelemetry NuGet packages? Yes, absolutely. One of the examples I'm going to be showing today is all .NET Core 3.1, and OpenTelemetry works just fine in that context. And that's because these packages and these interfaces all ship as sort of a separate NuGet package that's backwards compatible to .NET Standard 2.0. So you can just basically add a reference to that and you'll be good to go. But what I was saying about the performance here is that these libraries were designed for very high performance. I'm going to offer in the final section of our presentation today some tips for how to performance optimize your use of OpenTelemetry using some tools like samplers and filters, for instance. But just know that the base level primitives are all very efficiently designed inside the library. So now with that out of the way, we've kind of talked about why this is important, why now, and what it does for you. Let's talk about how we actually go about using it. So I'm going to begin by talking a bit about tracing at OpenTelemetry. So on the left here, these are the system.diagnostics names for stuff. And on the right, these are the OpenTelemetry names. So an activity source is basically what a library like ASP.NET or Akka.NET is going to use to emit tracing events. So every single logical operation, such as an actor processing a message or an actor being created, is going to create a brand new activity, or otherwise known as a span. That span is one logical unit of work. All of the spans that are part of, let's say, one logical request. So let's say a user sends a request to your web application, and then that web application is going to go ahead and send a message to an Akka.NET actor. That actor might message another actor. That actor might make a call to a database, and then it's going to send a reply back, which will cause an ask operation that you initiated in your controller to complete. Each one of those steps is one activity. And those activities are all correlated together through this activity context. I'm going to talk a little bit about how the correlation works, both in process and across the network. But basically, every time you do an await operation, we have this little propagation context that gets attached via one of the built-in tools inside the activity source / tracer. And that's going to go ahead and basically follow all those await calls all the way down. And then when your messages go across the network, we have to use a propagation tool to do that. And in Akka.net, we've built that into the way Phobos does Akka.remote serialization. So Phobos will handle that for you. In the HTTP client, they use a W3C tracing header to do it. In other systems like RabbitMQ or Kafka, you have to basically go ahead and append a couple of headers to each message on the way out, and then extract that trace context from those headers on the way in. That's how the propagation works there. And we'll dive into that in some more detail a bit later. But these are kind of the basic units of work here. That one thing you're going to want to do as a, let's say, an efficiency thing is you should probably stick your activity source or your tracer. That should probably be stuck into like a static read-only field, and you should have a singleton of that in your process. There's no benefit to having multiple tracers with the same name. You're actually just kind of creating a bit more work for the system to perform. So you want to go ahead and basically just usually grab a singleton of that. Each one of those activities that gets produced is going to be consumed by some subscribers. We're going to talk a bit about how the tracing infrastructure for OpenTelemetry works behind the scenes. But if there's no one subscribed to any of those activity sources, they get no ops. They essentially get garbage collected, and they don't get serialized or sent over the network. And these are all implemented, by the way, as like lightweight structs. So there's very little cost involved to any of this. It's not exactly zero allocation, but it's reasonably close to that. Now, a couple of the other important properties of OpenTelemetry's tracing is attributes and events. For each logical operation, such as an actor processing one message or one database query, we're going to attach some attributes and some events. So attributes you can kind of think of as like dimensions. If you're building an e-commerce system, you might want to go ahead and build some attributes for things like the order ID, maybe the customer ID, or maybe the product ID. That'll allow your developers using a system like Datadog or Jaeger to go searching for operations that affected that particular customer, or operations that all trace back to that particular user. So attributes are searchable properties of a span. They're basically key value pairs. So in Phobos, we automatically attach things like the type of message, the type of the actor, and the actor's location on the hierarchy as attributes by default. Next are events. Events are, think of it as like contextual data payloads. They're designed to help you understand what happened during the operation. So log events are a really common example of things that usually get attached to spans. We also take in Phobos, stringify the output of your message that you're processing. So if you are receiving, let's say, well, I don't know, a message that has, let's say, a custom to string property, you'll be able to see what the content of that message was each time an actor processes it. So this is designed to kind of help the developer figure out what's going on. Now, this is what creating activities looks like in OpenTelemetry. So this is from our first code sample we're going to show, which is a really simple ASP.NET application built in .NET 6. And I'm using Razor pages here. So I'm passing in this construct known as a tracer provider. The right way to do this probably would be for me to go ahead and just pass in the tracer directly and to create a singleton of it inside my my little service collection I'm going to use when I'm first configuring my application. That's probably the right way to do it. But I built this like this because this was meant to be a demo. This shows you how you get a tracer. You get a tracer usually by going and either getting a hold of the tracer provider and calling get tracer, and you pass in the name of your tracer / activity source here. Under the covers, this is creating an activity source is what's happening. And you want to use a constant to go ahead and name any activity sources that are specific to your application. That way, anyone who wants to subscribe to it can go ahead and get a hold of that same constant and bring it in. And then down here, we're going to go ahead and create a brand new operation, this little myOp operation right here. When I say start active span, This means that this is the new context that we're entering. And anything that gets logged or any errors that get thrown, we'll go ahead and attach back to this span. Now, if I had, let's say, if I go grab my little laser pointer, if I had an await operation, oops, that's the wrong tool. If I added a little await down here, and let's say I ran an entity framework query, that would go ahead and create another child span underneath that. And once that's a using block right here, once we call dispose on this active span, we're going to go ahead and restore the previous span in that context. So when my entity framework queries, that span will be complete and no more data can be added to it. But this span, its parent, is still open. And maybe if we go ahead and do stuff like send back the HTTP response, maybe some of that will get logged onto the span, depending on how we program it. But that's the sort of basics of how this works. And I'm setting an attribute, and here I'm adding a little event that I'll be able to see inside our tracing system. So for this code sample, this is a little personal repo that I built back in December when I wrote a big blog post on how OpenTelemetry works. We're going to go ahead and pull this up. So let me go ahead and grab my web browser here. And I'm going to drop a link to this in chat. Now, I've got this sample kind of already cloned on my machine here. So I'm going to pull up my command line. And the first thing I'm going to do is I'm going to follow the README instructions here, and I'm going to start Jaeger up and running behind the scenes. So Jaeger is an example of an OpenTelemetry compatible distributed tracing system. It's an off-the-shelf sort of open source piece of software, and it works at very large scales if you want to use it. And it's very convenient for doing demos. That's why we're using it here. And then down here, this is my web application that I built using .NET 6 and all the new minimal APIs. So you can see here, I've pulled in a couple of the OpenTelemetry NuGet packages. In fact, let me go ahead and edit my CS project. So I went ahead and I pulled in the OpenTelemetry. In fact, this should actually just be OpenTelemetry like that. Not that it matters since all these other packages reference it. But I've also pulled in the exporter for Jaeger, and I've pulled in some of the instrumentation for ASP.NET, the HTTP client, and SQL. So that way, every single time I need to go ahead and process, a web request, this ASP.NET Core instrumentation can help me go ahead and record that. And here's where we're going to go ahead and configure all of that right here. Is first, I'm going to go ahead and take my service registry. I'm going to add Razor pages. Next, I'm going to call this add OpenTelemetry tracing. And this is going to give me access to the tracer provider builder here. And so some of the things I'm going to start doing is I'm going to add Jaeger. Jaeger is going to be my exporter. So all of my completed activities are going to be exported to Jaeger for indexing and rendering. So I can actually visualize what was happening inside my system. Next, I'm going to go ahead and add a source. I'm going to go ahead and subscribe to all of the traces produced by my own application here. So I'm going to go ahead and subscribe to that source by just passing in the name of it right here. And the next slide, by the way, I'm going to show you how what this is actually doing, this call. Next, and this step is really important, I'm going to go ahead and add a resource. What this resource is going to do is it's going to contextualize where all these traces are coming from the point of view of my application. I can also optionally group them together into a namespace. And if I really want to, I can go ahead and identify each service instance individually. So I might go ahead and do service instance ID is dns.getHostName. Like that. And let me go ahead and let's see. Import. Yep, there we go. So this will go ahead. If I have multiple instances, let's say I've got 10 instances of this app running under a load balancer, I can figure out exactly which one it came from this way. Next, I'm going to go ahead and subscribe to traces from some of the built-in data sources. So I'm going to add HTTP client instrumentation. I'm going to add ASP.NET Core. And even though we don't use SQL, I'm going to go ahead and subscribe to that instrumentation as well. And then I'm just going to go ahead and have the rest of my little minimal config stuff down here. If I take a look at that Razor page I pulled up earlier, this is the code I was showing you on screen just a minute ago. This is my index method for the website. And we're going to go ahead and record this little active span each time we process a GET request to this homepage. So let me go ahead and shut my app down, and I'll start it back up again. Okie dokie. Here we go. So I'm going to go ahead and kind of just click around my web page some. And then I've got Jaeger running in a Docker container on its kind of default hostname and port. And we can see here my demo.asp.net service is available. And I can see there's 3 operations recorded here. All right, looks good. Let's go ahead and click Find Traces. So you can see I have 2 traces for this operation, but only, oh, sorry, 2 spans for this operation, but only 1 span for this one. So if I open this up, this is being traced automatically using the built-in ASP.NET configuration. So that's what's going on here. And I can see the HTTP route, I can see the URL, I can see even the user agent of the browser who initiated this request. And all that's coming from this 1 line of code right here, where I added the ASP.NET Core instrumentation. This is basically allowing ASP.NET to go ahead and, well, essentially it's subscribing to the activities ASP.NET automatically produces. So that looks good. If I go back here, I can see we have 2 operations here, and lo and behold, the first one is from ASP.NET again, and you can see that here. This is coming from OpenTelemetry.instrumentation.asp.NET Core. That's where that's coming from. But if I scroll down here to this operation, and you can see my little tag that I recorded, right? My little event that I recorded right here. You can go ahead and see this came from my demo.asp.net library. So this allows you to go ahead and kind of figure out where all these traces coming from for each of the different steps in your application. So this is a really simple, tracing example here using just a very tiny ASP.NET Core application. I'm going to go ahead and shut down Jaeger real fast because I'm going to need it again for my next demo. So the way OpenTelemetry works is you have all these disparate activity sources that are each declared independently inside each library. So ASP.NET Core has an activity source, Entity Framework has one, Akka.NET has one through Phobos, the HTTP client has one. And then when you're building your software, you might go ahead and declare one for all of your own events that you're producing inside your app. What happens is that when we go ahead and use that add OpenTelemetry tracing method, we get what's called the tracer provider builder, otherwise known as the OpenTelemetry SDK. And in this SDK, we're going to add subscriptions to all the different activity sources we want to include in our traces we're going to export at the end of the day. So when I go ahead and I call, add, HTTP client or add ASP.NET Core, what we're really doing is giving the tracer provider a name that it's going to go subscribe to, and it's going to start receiving those events when it does that. Under the covers, there's an eventing system that's built into system.diagnostics, and that's what kind of pulls all this information together, is this sort of eventing system that's been built into system.diagnostics for quite a long time. And that's basically where all those events are kind of being tapped into. That's why we don't necessarily need to pass around, let's say, a shared tracer object or anything like that. There's this built-in high-performance pub subsystem that Microsoft developed that's allowing us to go ahead and receive this stream of activity together. Now, the propagation piece is kind of the key to making tracing work. If you are using the system.diagnostics.activity library, you can look at activity.current and see what the current trace operation looks like. In fact, I might go down to our application here, and let me go ahead and add equals activity.current. Then I'll go ahead and add another one. And I'll add some breakpoints to both of these, and you'll be able to kind of see the propagation happening here. So I'm going to shut that down. I'll go ahead and start that back up. Okie dokie. Looks like I didn't hit my breakpoint. Let me try that again. Well, for reasons I don't quite get, looks like my breakpoints didn't get hit. Oh, I didn't run this in debug mode. That's why. Okay, let me go and add those back. Sorry about that. All right. That's more like it. So we take a look at this activity. Let's go ahead and evaluate here. Pull this up. This activity is Microsoft.asp.NET Core.hosting.requested. So that's the current activity. Now, when I go ahead and press F5 here, now the activity, if we take a look at it, is my op. So every time we call start active span, we're basically replacing this activity.current. Oh yeah, I know Jaeger stopped. It doesn't. So by the way, Jaeger stopping isn't going to cause the application to crash. By default, Jaeger uses a UDP connection, and if there's no one listening on the other end, those packets will just get dropped. So it's not going to hurt anything. But basically, what you can see here is this activity.current property is an async local, and its value is going to be replaced every single time we call active span. If I go ahead and change this to, let's say, an explicit using statement, which, by the way, this is a best practice. Having a using statement with the scoping involved, this helps ensure that your traces are all basically closed properly when you do this. Otherwise, if you come down here, it's not necessarily clear which span is active in each context when you use just a normal using statement. So this is a case where having using with a scope is actually really helpful. So let me go ahead and add this down here. Then I'll go ahead and do var final activity equals activity.current. So we go and add a breakpoint for this as well. And I'll go ahead and hit debug. We'll launch this real quick. And here we go. So activity.current should be that ASP.NET. So let me go ahead and let me flag that. Yeah, there you go. So it's HTTP request in, hit F5. Now it's my op, hit F5 again, and we're back to request in. So because we dispose this activity down here, activity.current returns back to whatever was there before. We're essentially restoring the parent scope of what we were in. So this is how context propagation works locally in OpenTelemetry. If I go and pull this back up, it all flows via async local, and the current span gets replaced each time active span is called. But once that active span is disposed, the previous scope is restored again. This is identical to how the scope manager worked in open tracing, which is what Phobos used to use before. In a distributed system, we have to include explicit span context propagation. So for instance, HTTP client in .NET will automatically do this by injecting a W3C tracing header, and ASP.NET Core can process that header, and we'll go ahead and use that to tie those two together. So if you have two web services calling each other using OpenTelemetry, you don't manually as a developer have to track any of that. That's all being done for you by the base class libraries. Phobos will automatically do this for you through Akka.NET serialization system. But if you're building a system, let's say that uses RabbitMQ or some other third-party technology, you might need to go ahead and build a little what's called a propagator to go ahead and do this for you. So I'll go ahead and load up this code sample real fast. And I'm not going to run it, but I'll go ahead and drop a link in chat where this is going to go ahead and use a little bit of a RabbitMQ behind the scenes. And if we take a look at their messaging project, I think you can see this little RabbitMQ helper. And let's see, where do they go ahead and do propagation? So activity, here we go. So you can see down here, not going to go through all of it, but this is where they're going to go ahead and propagate all of the span context information. They're going to propagate that into some headers in the RabbitMQ message that's being published over here. Or they're going to go ahead and inject it as tags, I guess, is the way they're doing that. And then on the receive side, whoops, that's the sender again. On the receive side, they're going to go ahead and extract that context back out down here. And they're going to go ahead and basically use this to correlate those traces together on both the sender and the receiver side of RabbitMQ. So context propagation, as you can see here, does not take a tremendous amount of code, but you do have to have a plan for how you're going to do it. And so in this case, it might be wrapping all of your RabbitMQ consumers inside a little bit of code that's responsible for making sure that tracing context, if it's available, gets preserved backwards and forwards. So that's something you'll have to do when you're working with, let's say, a technology like Rabbit. Phobos will handle this automatically for you, and Akka.net, ASP.net, and HTTP client will also handle it for you, but other technologies may not necessarily do that. And so these distributed traces, in terms of what's going on behind the scenes here, let's say you have these microservices all talking to each other. What'll happen is this operation will get completed first. This database query is the first operation that completes, and that might get reported to Zipkin. Zipkin's another open source tracing system, just like Jaeger. So that operation might get reported first to Zipkin because it completes first. Then the HTTP operation, you can see here the span ID is decrementing. So these are actually newer spans, but they're all completing first. And once all of these operations all complete together, you'll see a histogram that looks like this, where this operation took 210 milliseconds, this sub operation took 140, this operation took 140, and finally this database query took 40 milliseconds. So if you're trying to performance optimize these types of requests, you might do that by trying to figure out, why do we need 100 additional milliseconds of time around this database query? What's going on in this service? Maybe that'd be a good place for us to start. So that's sort of what the tracing output's going to look like for you. Now, the metric side of things works very similarly to tracing, but it's a lot simpler because there's no need to propagate context in the same way that there is with tracing. Metrics are basically somewhat independent from each other. So what we have in OpenTelemetry metrics is the concept of a meter. And a meter is basically the exact same idea as an activity source. And by the way, the infrastructure for gathering metrics is virtually identical to the way it works for tracing. So I go back to this diagram from earlier. The metric infrastructure is literally the same as this. It's all using the exact same type of named sort of source plus event propagation system that all kind of happens beneath the covers. So it all works the same way. But what's important about metrics is you have discrete types of basically meter, what we call metric implementation here. So first is we have counters. Counters are used for measuring rates and frequencies typically. So for instance, in Akka.net, we go ahead and measure message processing, actor spawns, and actor crashes as counters. That way you can go ahead and kind of build a picture of how frequently are these events occurring inside your system. We also have what's called an observable gauge, where this is an asynchronous gauge that runs behind the scenes. And this thing will just periodically, using the TPL, will go ahead and pull a value using a little lambda expression you pass into it. So in Phobos, for instance, if you're using Akka.cluster, we have a gauge that wraps around the cluster object, and it will query the current cluster state to visualize how many nodes are in your cluster, how many are reachable, et cetera. And an observable gauge kind of just does that automatically for us. And then lastly, we have a histogram. Histogram is very useful for trying to measure distributions. So for instance, if you want to measure how many bytes are in an HTTP request, you'd want to go ahead and use a histogram. And that way you can go ahead and plot, okay, how many requests do we have above this threshold or above this threshold? And the underlying telemetry systems will automatically bucket these for you. So we actually use histograms in Phobos, and I've got a whole separate dashboard for illustrating this. We use histograms for measuring latencies for different message types. So how many milliseconds per message type and per actor does it take to process, this message type that's built into my application? And we can even, in theory, break that down per node inside your system if you wanted to. So these are some of the built-in metrics types that are available. And we're going to go ahead and walk through sort of what those look like in just a moment. Now, I already kind of showed some of this code from my original application here, my little ASP.NET Core app. Both OpenTelemetry tracing and OpenTelemetry metrics are kind of constructed against the service collection, just like this. So if I go and pull this up, let me get rid of my breakpoints here since we don't need them. I'm going to go ahead and go over to program.cs, and I'm going to go ahead and do builder.services.add OpenTelemetry metrics like this. And I can go ahead and do builder.add, let's see, HTTP client instrumentation, builder.add ASP.NET Core instrumentation. And let's see, is this complaining about something? Okay. Oh, I get it. That's why I didn't like that. I'll go ahead and just change this to B in that case. So this will allow me to go ahead and start subscribing to metrics that are built into my application. And if I take a look at my NuGet packages, let's see, I can go ahead and do OpenTelemetry. Actually, you know what? I know how to do this one by hand here, so let's do that. I'll go ahead and add a reference to Prometheus. And I believe that should work. Let me go ahead and build that. All right, great. That'll work. And I could go down here and add, add Prometheus Exporter. And that would go ahead and allow me to start exporting metrics to Prometheus, which is one of these off-the-shelf open source solutions for gathering this stuff. So all this to say that configuration for being able to go ahead and keep track of metrics in OpenTelemetry is actually pretty simple. And in my opinion, a lot simpler than what we were doing with Phobos 1.x, because I don't have to worry about passing around these sort of these instances of meters and tracers and all that stuff anymore. It's all kind of happening behind the scenes for us. So the general sort of processing pipeline, and I'm going to go into some detail on these since we haven't talked about them as much. The general processing pipeline for both traces and metrics, as well as logs, is we basically have a source of where those logs and metrics come from. We subscribe to those sources when we are configuring our application. Each time a metric gets recorded or each time a trace gets a span gets completed, we publish that to a processor. A processor is a type of basically, before we export this to, let's say, Jaeger or whatever, we can go ahead and do things like filtering in there. We also have processors that perform sampling for being able to go ahead and rate limit basically how many spans are we exporting and serializing out to, a tracing system. So there's all sorts of interesting stuff a processor can do. And I'm going to show you some examples of how to build one. But then down here, we have our exporter. And our exporter is what actually transmits the completed data to our APM service. And this is basically, by the way, the exporter is really what the APM vendors are building. So Datadog and Jaeger and Amazon X-Ray and Azure Application Insights, they all have their own exporters that they develop. So now let's go ahead and finally talk about Akka Net Metrics. So this is the same slide I showed last year because the metrics really haven't changed. The only thing that's different is the way we're collecting them. So what sort of metrics do we want to try to capture with Akka Net? Well, we do want to understand, the level of CPU and memory utilization that's happening inside our system. Those are usually gathered for you by the platform you're running on. I do believe that Kubernetes, if you're using that, does export a whole bunch of this stuff natively to Prometheus if you're using that environment. But otherwise, usually your kind of host infrastructure is responsible for measuring this. But then there's your actual application metrics, such as in Akka Net, we want to go ahead and measure total message throughput by type. We want to know about latency distributions by message type. And we also want to know about actor crashes and that sort of stuff. In the log space, we kind of want to know about logging frequencies. In particular, if we see the error log start skyrocketing, we know that there's probably something going wrong and we'll figure out what it is pretty quickly. And then if you're running Akka Net clustering, you definitely want to pay attention to how big your cluster is and how many nodes are unreachable. Down here, we also keep track of latency. So Akka Net keeps track of just its message processing latency. How long did it take an actor to process one message? However, using something like a distributed trace, you can measure how long did it take this entire request end to end to complete. And you can actually aggregate metrics from a tool like Jaeger into Prometheus to build an end-to-end request tracing latency distribution. Or you could go ahead and create a histogram manually inside your controllers. And if you're sending your query to a cluster and you're using an ask operation to do it, you can go ahead and measure how long did that operation take. And that'll be a really useful way of trying to roughly approximate what's your end-to-end latency look like at any given point in time. And then finally, we have the observability piece, which is basically being able to go ahead and keep track of traces and logs inside the system. And in OpenTelemetry, what they basically have, I'm not going to go into too much detail on this because it's pretty simple, but essentially anything that can be captured with Microsoft.extensions.logging will automatically be correlated together via the log exporting systems that they have. But more importantly, it automatically gets attached to traces, all that log data. We already do this in Akka Net using the logging adapter system. So we capture that information as well. Now, in terms of why these metrics matter, these ones know if you're running too low or too high on your resources. So this affects your auto scaling. These metrics here are basically telling you who's doing work inside the system. Keeping track of your error rates will help you kind of understand. Well, these are your kind of important monitoring metrics, these ones, in terms of what drives error notifications. So you basically want to keep an eye on this because it'll tell you what the total health of the system looks like on a node by node and even potentially actor by actor basis. And then the clustering stuff can help you figure out if you've got split brains or other types of networking issues that might be impacting your availability. And then finally, in terms of these other metrics down here, measuring latency is probably the best way to understand how well you're serving your customers. That's usually the most useful business metric, but not always. Error rates can also be helpful if you've had some problems there. And then the observability bits, as I very glibly point out here, is primarily used for resolving arguments among your engineering team. And so in terms of the way we use them, we're going to go ahead and use these system metrics for doing scaling. These green metrics, we're going to go ahead and use this for essentially operations and planning. And then the blue, we're going to go ahead and use for tracing and debugging. These are the same slides I put together when we talked about what are the metrics you want to pay attention to in Akka Net. Phobos goes and captures all of this. Now, for our little demo we're going to use with OpenTelemetry, I'm using a public code sample that basically is designed to work with Phobos. And we're going to use Phobos plus OpenTelemetry, and we're going to use the brand new beta version of Phobos we released yesterday. So it's 2.0 beta 1. And we're going to automatically use Phobos to trace and correlate activity from Akka.net and ASP.NET Core. And we're going to use Jaeger, which we were just using a second ago. We're going to go ahead and use that to essentially visualize all that activity happening in that part of the system. And then for metrics, we're going to go ahead and use Prometheus and Grafana. And we're going to go ahead and build a little alerting dashboard there. And here's the code sample that we're going to go ahead and use to run this. And I'm going to go ahead and fire that up right now. So let's see. This is my Phobos sample. That's fantastic. Let's go ahead and dive into how this is all configured. So assuming you have access to Phobos, here's how we set it up. Same as we did before, we're going to go ahead and create a resource. That way, this specific instance of our service is going to be differentiated from all the others. So we're going to go ahead and basically just grab the name of our entry assembly, and I'm going to go ahead and set the service instance ID is equal to our DNS.get hostname. This is a pretty straightforward way of doing it, to be honest, is naming the instance IDs based on their host names, assuming that you don't have any overlap between host names. Okay, send the link to chat. Oh, sure. I'm sorry. I forgot to do that. Let me go ahead and grab it. Here you go. Sorry, Andreas. Okay. Now, if I go back to my code sample, so we create our resource first. Next, I'm going to go ahead and add my OpenTelemetry tracing. So I'm going to go ahead and set my resource builder to be equal to this. And then I'm going to go ahead and call add Phobos Instrumentation here. This is an extension method that Phobos introduces. And this basically causes you to go ahead and subscribe to all the traces and metrics Phobos produces. Next, I'm going to add a manual source. In this case, this is my own application here. Well, that reminds me, I got to add this down here as well. Let's see, I think it's add meter. Yeah, there you go. So I'm going to subscribe to that. I'm going to add my ASP.NET client, my ASP.NET Core and HTTP client instrumentation. And then I'm going to go ahead and add my Jaeger exporter. And I'm going to configure Jaeger to basically point to this host name. So rather than pointing to localhost, which is what it does by default, I'm going to run the sample inside Kubernetes so I can scale it. But we're going to go ahead and grab that data from an environment variable that I define. Where is that? Right here. So I'm going to go ahead and define my Jaeger agent host as this host name. This is going to map to where Jaeger is running inside my Kubernetes cluster. So that way we're shipping logs to the right place. And then down here, I'm going to add OpenTelemetry metrics. I'm going to add Phobos Instrumentation for that. I'm going to go ahead and configure a meter. And then I'm also going to go ahead and add our HTTP clients and our ASP.NET Core information as well. These I'm going to uncomment a little bit later after we launch the sample the first time. So I'm going to go down here. And after I've configured my NuGet.config to basically download Phobos from SDK bin, I'm going to go ahead and do build.command docker to go ahead and compile some Docker images here. This should take just a moment. Okay. All right, so we're just going and building our little Docker image. All right, that's all done. I'm going to go ahead and do deploy all and deploy my little Kubernetes cluster. All right, perfect. That'll take just a second to spin up. But if you take a look down here, you can see all the URLs for where you can go ahead and view each of these different services. So I'll go ahead and run my little application here. It's not working right now, so it might still be loading. Let me go ahead and take a look at what Cube Control has to say. Looks like Phobos Web crashed. Oh no, I wonder why that happened. Let me go ahead and take a look at the logs real fast. It's N Phobos Web logs, and that is Phobos Web 1. My guess is I misconfigured something. ASP.NET nodes. Looks like it's working. Okay, now it's working. So I don't know why it crashed the first time. Might have been something wrong with the way I'm doing it, but I can see tracing information showing up now. If I click on this, I can go ahead and see in Jaeger, my petabridge.phobos web application is here. And I can see we've recorded 17 operations so far. Let's go ahead and do find traces. Okay, so first thing I see is we've got a bunch of little HTTP post operations here that are showing up quite frequently in the logs. Let's see what these are. If I take a look here, this is coming from the HTTP client. And it's because we're actually uploading all of our, we're using serial log in this application. And I have a Seek sync for serial log. So all of our logs are being aggregated inside Seek right here. But every single time the Seek client does that, I'm receiving this trace back about all of those logs going through. So that's a little bit of noise we're going to have to clean up. And then let's see, what else do we have in here? Looks like I've got a couple of real operations that have some errors in them. So let's go ahead and take a look at that. Let's take a look at this cluster ask operation. So this is our real workload that's being executed here. If I take a look at it, we can see that we're on my third instance here. I can see this was recorded via my ASP.NET Core instrumentation, and this is when we loaded up our index page. This created a custom operation that I personally crafted here, which then starts stepping into Phobos at this point, where we go ahead and we created an ask operation here. Now, if I go and close this down, you'll go ahead and notice that in terms of the total end-to-end latency, this took 47.51 milliseconds to complete. Well, this ask operation right here was 43 of that. So most of the time that was spent here appears to be some of these little operations down below. So let's take a look at what happened exactly. So I went ahead and I asked this actor, this /user/forward actor running in process. I sent it the string that I asked here. I went ahead and I recorded a new operation. Let's see. Clock skew adjustment disabled. That's probably because the amount of time it took was so short. It's probably why that got logged. But I can go ahead and see here that we recorded a second operation and we spawned a new actor. And I can go ahead and see that actor spawning right here. And I can see the actor starting up. And then I can see the same actor that we just started receiving this event. And eventually it looks like this actor crashed and then restarted. And then it started back up again. So it looks like it took this actor a little while to start back up. So that might be because there was a bunch of system messaging happening backwards and forwards. that helps explain the latency that I'm seeing inside this picture here. Whereas if I take a look at this operation, so these operations where actors are crashing, we see they take, over 40 milliseconds. Whereas actually, well, this operation where an actor crashed only took 7 milliseconds. Huh. So maybe there's something going on with our scheduler down here that we should go and take a look at. This kind of helps explain what's happening inside each of my services so far. Now, as I go back to my little Jaeger UI here, let me go ahead and take a look at, let's see, all of our operations here. If I go to all, I'm really tired of these HTTP post operations showing up inside my trace. So I'm going to go ahead and let me go ahead and destroy my Kubernetes cluster real fast. I'm going to go ahead and fix that. I'm going to go ahead and destroy that namespace real quick. Let me get rid of that. That's my other application. And one thing I'm going to do here is I'm going to add a custom processor to our OpenTelemetry pipeline, this new filter processor right here. What this filter processor is going to do is this implements a base class from OpenTelemetry called base processor. And this allows you to, if I go back to my little diagram of the pipeline a little further up here, this allows you to go ahead and intercept traces and metrics before they're exported to a service like Jaeger or Prometheus. And for tracing in particular, this is really useful. Sorry, this is what we're working on now. This is really useful because it allows us to go ahead and get rid of noise we don't want inside our operation here. So now that I've added this filter processor, I'm going to go ahead and rebuild my Docker image real fast. And then we're going to redeploy the application, and all of those unwanted HTTP post operations should be filtered out by this. We're going to go ahead and filter these activities out by operation name. So these activities here are basically just going to get garbage collected, and we're never going to bother uploading them to Jaeger. So this should be just about done. Great. I'll go ahead and deploy everything once again. I'll go ahead and give that a second or two. In fact, let me go ahead and run my get all real fast. All right, looks like we're up and running. Go ahead and double check that. For some reason, Phobos Web 1 had to start again. Error. What happened there? Phobos Web startup. Resource temporarily unavailable. This means that the pod hasn't been assigned a host name yet. And so when we tried to go ahead and do DNS to get host name, the process crashed. So if I try running that one more time, now it's up and running. Okay, good. That's a bit of a nuisance, but that's kind of that's a Kubernetes issue. If I go back to Jaeger UI and I hit find traces, looks like my HTTP post is still there. So maybe my filter was not configured correctly here. Operation name contains, or you know what? The other issue might be I needed to bump my version of my Docker container. That's probably why that didn't work. So I'll have to go ahead and recompile that and do that one more time down here. Another thing I can go ahead and do is I can add a sampler if I want. If I only want to record, let's say 50% of all of my traces, that way we're not putting as much pressure on our APM infrastructure. And by the way, if you're using a tool like Datadog or Azure, this will have the effect of cutting the amount of data you have to consume in half as well. I'm going to go ahead and basically say I only want to include 50% of all traces. And we're going to do this based on the trace ID. So this is going to go ahead and basically cut our total number of samples in half. So I'm going to go to my release notes. I'm going to go ahead and bump the version number on this. And then I'm going to go ahead and update my service. So I'll go down here, change that. And I'll go ahead and build my Docker image here. Now, while that's running, I'm going to do, so one of the things I just did is I changed out my Docker version. So I'm going to do a live deployment to my entire Kubernetes cluster here. One thing I'm going to pull up real quickly is we're going to take a look at some of the data that's being produced by OpenTelemetry metrics, since we haven't spent as much time with that so far. So these are some of my old dashboards from Phobos 1.x. I'm going to go ahead and import some new dashboards that I built specifically for OpenTelemetry. So I'm going to go ahead and grab this Grafana dashboard from Grafana Cloud. I'm going to paste this in here. And we're going to select this Prometheus data source. And let's see. It's going to tell me I have a bad gateway. And why is that? If I go to data sources, Prometheus IP service, error updating options. Go to edit here real quick. If I try that, that fixed that. Let me just go ahead and double check my Prometheus configuration real fast too. Prometheus query UI. I think I know what's going on here. Let me go to my Kubernetes cluster. I think Prometheus is down right now. And that's because I'm running, yes, it is. I'm running on a very tiny number of cores right now, since I was recently using this machine to debug some race conditions. So let me go ahead and control. I'll go ahead and do delete. And I'll go ahead and delete, let's see, deployment.app/seek. All right. Let's see, get paused. Hopefully that'll go ahead and free up some resources for Prometheus to deploy, since that's kind of pivotal to making this whole demo work. Otherwise, I'm going to have to restart Windows subsystem for Linux on here, which is easy enough to do. Yeah, let me do this. Start. Grab that. That's still pending. All right, well, I'm gonna have to start my demo over real fast. Destroy all. And thankfully, we have documentation on how to do this in our community section at Akka.net. Documentation guidelines, debugging Akka.net. And let's see. Yeah, let me go ahead and fix this real quick. I'll go ahead and go to PowerShell. This is my problem, is the number of processors that I have. Go ahead and shut down Docker real fast. Let's see, I think I need to go ahead and terminate. Yeah, WSL list. Go ahead and terminate. And I'll go ahead and restart Docker. Yep. Okay. Well, sorry about that. That's what I get for not running my demo on the machine I was going to be giving it on. Okay. That should be up and running in just a second there. Great. And let me go ahead and check Kubernetes real fast, provided that's all started. Looks like Kubernetes is still starting. Okay. Let me go ahead and give that just a second to start. That should go ahead and be done any second now. I guess while I'm waiting on that, go ahead and make sure WSL is up and running at least. Okay, now it's up and running. Good. And Phobos Web get all. No resources found in the Phobos Web namespace. Okay. Well, let me go ahead and do this. We'll go ahead and redeploy everything. Okay. That is grand. Get all, let's see. And take a look at my pods. Looks like everything's running now this time, I think. So many things to know. Docker, Kubernetes, Windows Subsystem for Linux, Grafana, Phobos, Hotel. Did I miss any? You shouldn't need to know about the other stuff I was running into there. Why is Prometheus stuck in pending? And the Phobos Web. Grab that real fast. Describe. Failed scheduling, 0 out of 1 nodes are available. 1 insufficient CPU. Welp. Let me go ahead. Go images. Go to my Docker settings real fast and scale that up. Able to double distribution there. Resource limits are managed by Windows. All right. I need 2 processors in order to get Prometheus to work. Okay. Try that one more time. Go ahead and set that equal to 4. And I'll go ahead and restart Docker desktop. We'll give that one more shot. Otherwise, I'm going to have to send you all a YouTube video afterwards. Let's see. All right. Plus, the dashboards are the best part of this whole thing. Okay. Now let's give this a shot. Although Kubernetes is still starting. And last thing I'll take a look at. Pending. Pending. Oh, gosh. All right, try that. So I'll go ahead and just shut WSL down altogether. And then I will go ahead, restart Docker one last time. Docker engine is starting, grand. Go ahead and see if WSL is up and running. All right, perfect. Anyway, if you're working with, let's see, pending, crash loop back off. Let me go ahead and basically delete my cluster and start all over again. And see if I can go ahead and get that rescheduled. This was definitely not part of the plan. I know you're all very impressed with my live Kubernetes debugging demo skills, but this all worked fine on my machine in the office yesterday. Yeah, I'll get this up and running in just a second here. And let me go ahead and just double check. And here, this stupid thing started up after all that trouble. After all that, and it actually went ahead and deployed. Okay. And that thing should be toast in just a second here. In fact, you know what? I'm going to give this thing a little nudge. There we go. Okay. Let's go ahead and deploy this all. Forbidden, unable to deploy new content to the namespace because it's still being terminated. No resources found. Okay. All right. Unable to create stuff from the Phobos namespace because it's being terminated. Okie dokie. Well, in that case, I'm going to change the namespace, which will now be Phobos Web 2. There we go. Namespace Phobos Web not found. All right, that did not work as well as I hoped. Namespace YAML. All right, let's give that a shot. That's looking more like it. Okay. Let's go ahead and query what's in here. All right, looks like everyone's happy. Our server should be up and running again in just a second here, and I'll have a chance to go ahead and visualize what's going on inside our cluster. So let me go back. I'm going to have to reload everything. Yes. Admin. Skip that. All right, yep, and that dashboard is not found because we have not imported it yet. So I'll go here. I'll go ahead and copy this dashboard. I'll go back to Grafana, load it, connect it to our Prometheus data source, and import it. And so far, it looks like we don't have any data just yet. That makes sense to me. And you know why? I'm pretty sure it's because this is all, let's see. Wonder if I'm querying this stuff against, if I go back to our code sample, let's go ahead and take a look at Prometheus. All right, and I can go ahead and see, if I go ahead and click execute, total number of log events that have been recorded by each node. There we go. Now we're starting to get some metrics here. So I've got one unreachable node right now and two up nodes currently. And this data will also start showing up shortly by the looks of it. So go ahead and click edit. Akka logs events. Yeah, that looks right. So I'll go ahead and give this a chance to refresh here. There we go. Looks like data is starting to come in for that. Data is starting to come in for this too. So good. All this stuff is slowly starting to get populated now that the cluster has been started. So we'll give that a little chance to play catch up. Now I'm going to import one new dashboard. So if you've been using Phobos already, you're probably seeing that dashboard that I'm showing there. We built that about a year ago. This one is a little bit of a work in progress, but I just built this one yesterday. And this is our latency distribution dashboard, used for being able to go ahead and measure how long it takes to go ahead and process each different message and for each different combination of, let's say, actors in the scene here. So my petabridge.command listener, if I go to, let's say, let's go ahead and take a look at this actor. There we go. So this is going to show me sort of my latency distribution. Now, there's not enough data accumulated so far for me to be able to go ahead and put together a big heat map. That's going to go ahead and gradually get populated. But I can go ahead and see what sort of percentiles my message distribution kind of lives in. So these are for ints that are being sent around inside our application. And I can go ahead and see that of all of the ones that we've captured so far, looks like the majority of messages handled via this type of actor all fall in the basically under a millisecond worth of latency. That's what this bucket is. And then we've had one message that was basically somewhere over 1 millisecond, but between 5 milliseconds. And you're going to go ahead and basically see as this data starts getting recorded, you're going to go ahead and basically see these distributions get a little bit more mature behind the scenes. So that's this sort of latency distribution graph here. Then in terms of the other dashboards that we have, if I go and pull this up, you can now go ahead and see our log distribution showing up here in terms of the amount of logging that's going on. You can see the total number of exceptions thrown by type for each of these different nodes here, the total errors logged, the total requests per second in this system. And you can go ahead and see what our throughputs by message type are. And right now we're going and recording these over the past 5 minutes or so. So these dashboards we're building against OpenTelemetry are still in a bit of a beta stage. We're probably going to go ahead and do a lot more work on doing things like heat maps. So you can basically view like what's your message distribution by minute kind of look like. So that's why Phobos is in a bit of a beta stage right now, is that OpenTelemetry metrics has given us the ability to express much more rich and sophisticated data types than what we were able to do before with app.metrics. So we're going to be taking advantage of that and trying to give developers a much better picture of what's actually going on inside their system. Now, one thing I always like to do when I'm showing this off is I like to go ahead and scale my, let's see, we'll go ahead and call this stateful set Phobos Web. I like to go ahead and scale our cluster. Oh, that's what I did wrong. So we're going to go ahead and go from having 3 nodes to having 10. And if I go ahead and do, let's see, get pods watch, we'll be able to go ahead and see these pods start spinning up. And so you'll see that we've gone up to 4 nodes. Then we'll go ahead and creep up to 5, 6, 7. Yep, there you go. You can see the pod counts are increasing here. You'll go ahead and be able to see a graph of like the status of each of these nodes changing over time. And also our requests per second and our throughput should all start growing up while we do this. Yep, so the request per second should increase, our total message traffic should increase, and our latency distribution curves will start to change as well when this occurs. So this is all basically kind of what we had before with Phobos 1.x, but now we're using OpenTelemetry to do it, and it's much easier to do things like put together these types of little latency distributions here. So now we can see, in terms of this bucket, and to make this a little bit easier, yeah, that time range works okay. Our message volume is not quite high enough to produce an interesting graph there. This is a little bit better. So you go ahead and see that we've had, one message, and this is basically, by the way, spread out, I think, every 30 seconds. So we had, 9 messages that basically fell on this latency distribution. We've had some here. If we had a much busier system, you'd go ahead and begin to notice, yeah, here we go. We're having the latencies beginning to increase in a couple of areas as well. This is using some of the metric types that are exposed in OpenTelemetry called histograms to go and measure this. Whereas most of what you're seeing over here, this is mostly based on counters, although this is actually using a gauge to go ahead and measure all this stuff. So it looks like one of our nodes got detected as unreachable. This should level off in a minute. Yeah, there we go. Everyone's now being tracked as up. So we now have a healthy cluster. You can see our logging activity is scaling with the number of nodes in the cluster added, and our requests per second has gone up a little bit as well. This system is basically just using the health checks from Kubernetes to go ahead and drive most of its traffic in here. Now, if I go back to Jaeger and I hit reload, and I'll go ahead and hit find traces. The HTTP post is still showing up, and I don't know why. So maybe I wrote my, maybe I went ahead and wrote my filter wrong. You can see down here, we're back to keeping track of some of our operations around, around our actors. That's all still showing up. And we have our samplers now running behind the scenes as well. So we're going to be filtering out all of the, we're going to go ahead and be filtering out about roughly 50% of all the unique traces inside our system. So that's basically a little bit of basics around sort of how OpenTelemetry works in practice. Now, to go back to show you how we configure things real fast, we have our OpenTelemetry builder. We have another one for metrics. And the key line for kind of making Phobos work is adding this add Phobos instrumentation call. That's what will go ahead and allow you to subscribe to the Phobos metrics. And then down here, rather than getting an iTracer and an iMetrics route, which is what we did in Phobos 1.x, you just grab a meter provider and a tracer provider. I'm pretty sure by the time we release Phobos out of beta, we're actually going to be able to get rid of all this. And you're not going to need to do anything other than this line here, where you go and specify your provider selection. OpenTelemetry kind of eliminates the need for a lot of this stuff. It's just that in the course of trying to go ahead and get all this out there in front of users and get some beta feedback, we're kind of gradually reshaping some of our APIs to make them easier to use. So that's what this all looks like behind the scenes. Now, if I go back to our presentation real fast, we talked a bit about our dashboards already. I want to finish up today before we take some questions by talking a bit about some known OpenTelemetry limitations and best practices. The first known limitation is that OpenTelemetry metrics is still very much a work in progress. There's no up-down counter, which is one of the important data types. This is basically for being able to track oscillations in things that are happening inside the system. That's not really supported yet. Exemplars and views are still a work in progress. An exemplar is basically a point in time representation of a metric. So a good example would be if we're taking a look at that chart showing the changes in, let's say, the state of Akka.cluster. If I had an actor that was tracing all the different reachability events that were occurring, I'd be able to go and correlate that sudden change in that gauge value with the trace that occurred at the same time. That way you could go ahead and basically produce something like an annotation inside Grafana that says, this is why this metric changed in value. So this is a really cool set of features that are still somewhat of a work in progress in OpenTelemetry. But the biggest problem with OpenTelemetry metrics is the number of exporters is very limited right now. Prometheus is basically the only game in town for OpenTelemetry's metrics exporting as far as like what the literature talks about, all the demos use it. And that's because OpenTelemetry's standards for metrics were really based around a lot of the standards that Prometheus developed. Now, I know most APM vendors are very furiously working on adding support for this. And this information I'm giving you might already even be out of date in terms of what exporters are available for metrics so far. But these are kind of the biggest issues with OpenTelemetry metrics. And that's why the OpenTelemetry libraries are still shipping as release candidates, not as fully fledged sort of mature libraries right now. It's because the metrics piece is still a little bit of a work in progress. Now, there's also another feature of OpenTelemetry that I didn't get into at all called baggage, which is a way of propagating like useful context inside your application. Phobos definitely does not support it yet. We're going to add support for it before we release beta. But baggage is a concept that is somewhat decoupled from both tracing and metrics, although it kind of functions the same way tracing does. It's not very well documented or explained, and it's not supported at all in the system.diagnostics libraries. This is all built into, this is all basically kind of like built built into the OpenTelemetry standalone library, and it's somewhat orthogonal to everything else that OTel does, but it used to be part of the open tracing spec, and that's why they have it. So in order to use baggage, you basically have to do manual context propagation. Again, the HTTP client ASP.NET will handle baggage for you, but it's a little bit of a manual kind of thing today. Now, some best practices I should go ahead and refer to. First, check your WSL config before you start your demo. That's one I'm going to be practicing going forward. But second, always define your resource to include both a service name and an instance ID. So if I go back to my Jaeger for a second here, and let's see, where did I stick that? Well, no worries. Pull that up. And if I go and click Find Trace, and if I scroll down to one of my bigger operations here, you go ahead and see this is from Phobos Web 8. So this allows me to go ahead and say, you know what, I am from, if there's a problem occurring, I know which host it's on, and I can go looking for logs that correlate with this. So you want to go ahead and always make sure you go ahead and specify what your instance ID is. That's going to be very useful for troubleshooting where a problem occurred exactly. So make sure you always define one of those. Next, wrap spans inside using blocks. Otherwise, you might end up accidentally leaking context, or the active context when you start disposing stuff may not be all that obvious right away. So I recommend using the explicit scoping mechanisms for those spans. That way you know exactly when one context ends and another begins. Have logging infrastructure eject events directly into your active span. The Microsoft.extensions.logging package will do this. So will Akka Net. So that should be taken care of for you across most cases. And then lastly, always make sure you cache and reuse your meter and metric instances. So to show you a little bit of manual code around OpenTelemetry metrics real quickly, let me pull up the Akka service right here and take a look at one of my actors. Here we go. So I'm going to create a little timer for basically measuring processing time. We're already automatically do this inside Phobos, but I wanted to show you an example of how to manually create one of these. So I'm going to create a histogram that measures a double. All metrics in OpenTelemetry can support either long integers or doubles as the two data types they support. I'm going to call this processing time. I'm going to say the unit, the unit is milliseconds. And so what I do here is I go ahead and I start by, with one date time, then I get another date time, compute the total milliseconds, and I call processing timer.record. And this will go ahead and show up in Prometheus. If I pull up my web browser here, let's see, here's Prometheus. If I go ahead and take a look at processing time, what was that? What did I call that metric? Processing time. There we go. Grab that. Go ahead and hit execute. And you know what? Looks like, let's see, meter, processing time. Why would that not be showing up on here? Processing time. That's showing up as a histogram. So I'd expect to see that somewhere on here. Processing timer.record. Maybe this actor is not getting that many messages. It should. Well, I need to go ahead and take a look at why that is not being. Oh, you know what it is? It's because as soon as this actor crashes or shuts down, this thing's getting GC'd. Okay. Well, in that case, my advice applies double here, which is if I go down to here, cache and reuse meter and metric instances, the bug in that code I just showed you is the fact that I'm not doing this. So basically those instances basically pre-aggregate data before it's injected into the meter. You don't want to go ahead and create an object every single time you increment a counter or a histogram. That's going to create a lot of garbage collection pressure. So you want to try to cache these and stick them into a static object that you pass around through your application. That'll help improve your performance significantly if you do that. So make sure you're always caching and reusing those. Next, carry domain-specific data inside your attributes. So if you're passing around information about customers or products or orders, you want to make sure that information all shows up inside your trace. So you can go ahead and search on it inside a system like Jaeger. So if I want to go ahead and search, let's say it's akka.actor.path, grab that. So I want to go ahead and look for this here. Actor.path equals user/console. I'm only going to find the traces where this user/console actor shows up. Or if I want to look for a more specific type of actor, let's say, yeah, that looks good. /user/console/9. Go ahead and run this. That's going to show me a much smaller number of operations potentially. So you want to go ahead and use those tags to make it easier to kind of figure out what you're looking for. And then the last couple things I'll mention is like use attributes carefully. You need to go ahead and be mindful when you're going in and basically are keeping track and measuring things of how many, it's called the curse of dimensionality in a metric system. You don't want to accidentally explode out of control with, let's say, hundreds of different dimensions for measuring each metric. That's going to increase your bills significantly on a platform like Datadog. It's also going to really increase the cost of keeping track of all this stuff. Yes, James is exactly right. Basically, this will go ahead and absolutely nuke your bank account from a point of view of Datadog. So use attributes very sparingly. I think we try to limit it, all of our metrics. I think we keep track of the Akka.net node address. And I believe we also keep track of the Akka.net cluster role. We might very well get rid of both of those, since that information can also be captured via the service descriptor. So we might get rid of all of that. Lastly, I think I forgot to finish writing this slide, but use samplers in busy systems. These basically allow you to go ahead and filter. These allow you to go ahead and basically reduce the total amount of stuff you end up writing to Datadog. This will also help protect your bank account. And lastly, some of the instrumentation supports upfront filtering of traces and metrics. That's even better. That actually stops the metric from even being recorded or the trace from being recorded, which prevents allocations from happening inside your system. And the last thing I was going to say here is become familiar with processors, which is what we did earlier to go ahead and keep track of these unwanted operations we didn't want to have inside our system. So that's all I have for today. So we're finishing right at noon. I'll go ahead and take some time for questions now. But thank you very much for attending. If you're interested in Phobos, you can go ahead and check out the link below. Otherwise, I'd be happy to go ahead and take any questions people might have. So I'll go ahead and leave that slide up. Okay, first question from Gareth James. I think Vagif asked a question earlier, so let me scroll back up to that. Okay, Vagif, your question was, if an application built using Akka.net already uses metrics and distributed tracing dashboards with pre.NET 6 OpenTelemetry packages and Phobos 1.x, are there any significant messages that come with .NET 6? So if you move to, let's see, there's no significant differences at all. The one thing you will have to do, though, is all those dashboards written without OpenTelemetry do need to be updated to ones that do. And the reason why is OpenTelemetry changes the way namespaces get reported from metrics. So that's the only reason why I need to change it. For me, it was literally doing like search and replace inside the JSON for our dashboard. And that got everything up and running. Otherwise, there's no major significant differences there. We're going to look at retooling the dashboards to try to show more richly detailed information, because OpenTelemetry's metrics capability, in my opinion, is actually more robust and performant. So we can afford to basically make some bigger bets on stuff on the metric side to go ahead and show you what's going on. On the tracing side, the difference between Phobos 1.x and 2.0 is negligible. They're virtually exactly the same in terms of how they function. The only difference I'd say is that by the time we're done performance optimizing Phobos 2 should be significantly faster than Phobos 1. Let's see. Let's take a look at some of the other questions here. A question from Gareth James on processors. What happens to a trace if you use a processor to filter out a span other than the root? Does the trace get broken into two traces? Yes, absolutely. So the way a sampler works, if I go ahead and pull up, let's see if I have a link to this. I do not have one. I was about to pull up the source code for what a sampler does, but a sampler basically filters things out by the trace ID. That way we can try to go ahead and remove the entire trace. If you use a much simpler processor and you do what I did here, I need to debug this a little bit. It was working yesterday in terms of why my processor did not work here. But basically what I'm doing is that if these operation names show up, I'm basically going to go ahead and filter those activities out. And that possibly means breaking the middle of my trace. So one thing you could potentially do if you wanted to is if you end up producing really giant traces, you could actually use a post processor to try to cut those up into smaller ones if you really wanted to. That is a possibility. More often than not, though, what you should look at here is like if there's operations that you know add very little value to the sort of design of your application, you can go and filter them out here. Let's see. Question from Arthur. We have scene message latency metrics. Does Phobos expose metrics for mailbox sizes as well? So in Phobos 1.x, we have a gauge that keeps track of that. We have not added those back to Phobos 2.0 just yet because they don't really have, I would have to allocate an observable gauge for every actor, which would be ridiculously expensive. So we're probably going to refactor that to use a histogram. In fact, I'm thinking about actually using histograms for just about everything, for keeping track of message processing latency, the frequency with which messages are tracked, and the distribution of messages that are being distributed inside your app. So I'm thinking about measuring all of those. Let's see. Do you have a date for when 2.0 will be out of beta? From Jack. So Jack, to answer your question about 2.0, so one thing we're going to have to depend on in order to get it out of beta is OpenTelemetry itself is going to have to be out of release candidate mode, because there's a chance they could go ahead and maybe theoretically release candidates aren't supposed to have breaking changes in them per Microsoft's own release standards, but we've all been through the ASP.NET Core saga. We know how that goes. But in theory, they could go ahead and maybe change the behavior of the system. Even though the APIs are the same, the behavior might change. That might force us to have to retool it. So we are somewhat dependent on when OpenTelemetry takes care of that. That being said, from the Phobos side of things, we have a list of issues. In fact, one thing I'm gonna go ahead and commit to doing, if I go and pull up our browser here, we have this issue tracker for Phobos, which let me go ahead and grab that. That's just on GitHub. I'm going to migrate some of the internal issues that we filed inside. So we have like a private repository where all Phobos' source code lives. I'm going to migrate some of the issues I documented during the port there, and we're going to put them out in public as a milestone. That way you'll be able to go ahead and track their progress, Jack. And the number that I've given to other customers who've asked, when are we going to be done with this, was by the end of the first quarter or by the end of April. I can't remember. It's on the blog post where I announced plans to do this in December. But we expect we'll have it done by then. Most of the heavy lifting has already been done. Now we're basically chasing down edge case bugs, doing performance optimization, and trying to simplify the config is what we're working on now. All the key features still work. Okay, question from Jay. Aaron, long ago we tried Phobos, but it didn't play well with our actors built from it, from the at least once delivery actors, because it's something to do with persistence, if I remember correctly. Has this been addressed over the last few years? Well, thanks to the people from, there's many people from this company attending this call, so I will not name them. But earlier this month, I was given an urgent task to go ahead and add end-to-end Akka Net persistence tracing support. And Phobos 1.x supports that right now. Although I have not tested it with the at least once delivery actors, so I'll file an issue for that. And Phobos 2.x includes all those changes. So we actually support end-to-end tracing with Akka Net persistence now. Let's see. Question from Dionysus. Is there a network impact, as in extra bytes on the wire, when having Tracy enabled in a relatively chatty clustered environment? So there's a minimal amount of network traffic impact, because all we're doing is basically wrapping we're basically wrapping your Akka Net remote messages in another payload that has the trace context on it. So in terms of the extra payload, we're talking, that stuff all compresses pretty well, but I would say maybe we're adding an additional 30 or 40 characters per message, because those header IDs tend to compress pretty well. And in fact, if I really want to get creative, I might be able to even compress them down into like a single, like long integer, basically. That's a good idea. Maybe we should work on that. But the header should be minimal. The thing that's expensive is if you want to use the baggage propagation, which we don't even support yet. That's going to basically mean like essentially sending stringified objects backwards and forwards over the network. And if you don't use it, there's no overhead. It basically it just doesn't get populated. But we are going to add support for that before Phobos 2.0 exits beta. There will be overhead if you use that. If you're building a relatively chatty application, I'll just avoid using baggage altogether, just because it's A, if you don't need it today, you probably don't need it tomorrow, but B, because it'll definitely greatly help reduce your overhead. All right. Now, I apologize to the people on YouTube. I've kept that tab closed, so I've not been looking for questions on there. If you want to go ahead and mention me on Twitter, my handle is Aaron on the web, and I'll be happy to answer any questions I might have missed there. Otherwise, I'll try to maybe address some of those in the YouTube comments. But anyway, thank you very much for your attention and time today. Apologies again for the technical difficulties I had with my WSL instance, but I want to thank you all for your time and attention, and I hope the recording turns out well. So thank you very much for your time today, and I'll see you all next time. So take care.